frequency. Now we discussed this topic and we have talked about it, but I just wanted to use the terminology that we haven't done so up to this point. So it's another expression to describe experimental probability. So do you remember there's the theoretical probability? So for example, when we throw a dice, the probability of a certain number coming up would be 1 out of 6. Yes, remember that? Because there's only one of each number and there's 6 sides. So that's theoretical probability. But it could be that we have experimental probability. Do you remember we did it with the M&M, the Skittles? And we found taking out, so the more time you do something, the better the probability gets. Yes? Do you remember that?
That kind of stuff.
Pardon? Yeah, I was going to say it. So here we go. For example, suppose a metal nut was tossed in the air 50 times. It finished on a flat side 41 times and on an edge 9 times. So here's our edge, there's our flat side. What we've got here is the outcome that we had. We've got our 2 options, flat and edge. Then our frequency. So this is the word, these are the kinds of words that we perhaps are not used to. Frequency means how often something happens. If it's frequent, it's happening a lot, yes?
Yeah.
I'm sure you've heard the word before. So our frequency for flat would be 41 and edge would be 9. Because that's how many times these things happen. So here is relative frequency. So this is essentially the probability we're looking at. Why is it 41 out of 50, Maya?
Because that's how many times I get it.
Exactly. Okay? So that's 41 over 50 and then 9 over 50. We could leave them as a fraction. They've changed them to decimals as well. And we know that if we were to add those 2 probabilities up, it has to total 1 for 1. If it doesn't, we've made a mistake somehow. Okay? We're going to try one for ourselves. So you need to get into groups of 3. So 1, 2, 3. 1, 2, 3. And when the girls come back, we'll do a 3 here. Alright? Now, what you're going to do...
Wait, where am I going to bathroom?
Yes.
And then Kaya will also learn.
Correct. So, we're going to... Do we know what tally is?
1, 2,
A little...
3, 4,
Exactly. So 1, 2, 3, 4, and then when we get to 5, we point it out. You talk about it here, we're doing an activity. You need to go and get your original what's it.
Original ones.
Original what's it.
Okay.
So, you're going to each... Okay, so first of all, you're doing this on your own, but you're with your group of 3. So you're going to each have a drawing pin, or thumbtack, whatever you call it. And you're going to drop it on the table, so you put it up a little bit, not 17 miles in the air. I can see some of you.
like this.
No, just do it.
Like
Then
you
you
say,
No, just hold it so it doesn't fall off of the table. Alright, so you're going to drop it and you're going to see, does it land flat? Okay, on its back or on its side? And you're going to tally each time it does it. So you can tally back or tally side depending on where it lands. Okay? You're going to each do it 60 times. 60. 60. 6 O's. No. Okay? 60 times. Alright, so for example, if I had 26 and 34, it would be 26 over 60 and 34 over 60. And we know that the total of that would be 1 or 60 over 60. So here, this is what we're going to do now. So you're going to compare your results with the other 2 people. So in your 3s, you're going to say, oh, well, I got this, I got that. Are they the same? Why or why not? So think about why they may be the same or why they may not. Then you're going to estimate the chance of a drawing finishing on its back. Estimate the probability of it finishing on its back, okay? Then you're going to combine your results to make 180 tosses. So, in the next thing here, we don't need to have tallies, so I just put a chart, so this is your small group results. You're going to add up how many you got on the back from all 3 of you, how many you got on the side from all 3 of you, and then your new relative frequency will all be over now 180. Okay? I didn't write the whole class because I wasn't 100% sure that everyone was going to be here today. Okay? So then what we're going to do is join the whole class. So going back to this. So we're combining the results of our group, and then we're going to do the whole class, and then answer those other two questions. So get combining. So for the back, what's this back group? What did you get?
So we got 110.
110. Front group, Maya 120, and other Maya. Pardon? 101. So what do those three numbers add up to? Oh my giddy aunts. Okay, so the side. Okay, who can tell me a quick way of finding the side total?
Just 230.
Abby?
540 take away 300.
Awesome, good girl. 540 subtract 331. What's that?
It is 200 and I'm doing mental math here. So,
Oh, good girl.
200 and okay. Yes, 200. So it's 209.
Mm.
209. I just started it, Sarah.
It started off extremely well, Sarah, and I was very impressed. It just.
I just went and I was like, it's 209.
Okay. Oh my. All right. So now, relative frequency. Remember, we're now doing 331 over 540 and 209 over 540. Now, maybe we should convert these to decimals so we can compare them a little bit more. So who can change? Oh gosh, girls, stop being silly. Who remembers how to change a fraction to a decimal? So this is early on work, a fraction to a decimal. Georgie?
331 divided by.
Good girl, because remember the line in between the two values means divide. So who can do that on their calcs for me?
331 divided by. Okay, so what is it?
612 recurring 96.
0.61.
8 recurring.
No, 2.
Slowly. Oh, I did 3,000.
All right, we'll just do roughly 0.61. That means that this one is 0.39. How do I know it's 0.39? Maya. My Maris. How do I know it would be 0.39? Well, I didn't even put 209 over 540 in my calc. If I knew that this one was yeah, 100 minus 61. Good. That gives us the 39. Okay, so which is more likely to happen then?
The back.
The back. Okay, so our class results have found that the landing on the back is more likely than landing on the side. Okay? Now, obviously, we could do this probability another time, or we could look back at your small group results. Were your small group results similar to this, or were they completely different? Completely different. So what did you find for your small group results? Was it more likely the back or more likely the side?
The back.
The back was still more likely, was it? Oh, that's interesting. Oh, how about your individual results? Were your individual results, did they all tell you that the back was more?
Yeah.
Oh, well, there you go. So, going back to the questions they were saying, so we've combined up, what's a set? So it says, which set of data gives the best estimate of the chance of a drawing pin finishing on its back? Is it your individual? Is it the small group? Or is it the class results? Which is the best estimate? And why? Georgie? Good. The class results because there's more data. So with experimental probability and relative frequency,
So the more times we do something, the better the representation of what's actually going to happen in the future. Okay? If you had just done it a couple of times, it wouldn't be as representative. Okay? So there are now some. Oh, so what does it say here? Experimental probability is the relative frequency. Better to use a larger sample size. So here, looking at this example here, it says the population is not made up of exactly 50% males, 50% females. The table shows percentage for several age groups for the Australian population. Estimate the chance. So again, we've got that word chance. They haven't necessarily used the word probability. That if you met a person in the 5 to 14 age group, that the person would be male. So we're estimating the chance that if you met a person in the 5 to 14 age group, that the person would be male. What do we think the answer is to this question? Which of these things are we looking at? It's not a trick question. Sarah? Not well. That's what the table is looking at, but they've separated into age groups. So for our example, what are we looking for, Georgie? Yeah, so we're only looking at this group here because the question has says 5 to 14 age group. Yes. What's the probability that the person's going to be male? Again, it's not a trick question. Kaya, what's the probability that the person's going to be male? 51. Let's keep it as they've written it. Pardon? 0.3%. Done. What's the probability they'd be female? Maya B? Maya B? Almost. 48.7. Good girl. Okay? So in some cases you're looking at tables representing stuff. So I'm now going to get you to have a go at these questions here. So for the first question, you're going back to look at this table. Okay, so you're using this information. If you've got a space, you can write it on the pack, and the answers are all there on the back page. Okay, so just for the last few minutes, you're going to have a go at that stuff.